Discoveries and of course the revolutionary mission of the James Webb Space Telescope continued. The new super telescope once again provided us with breathtaking images and data in 2024. James Webb is revolutionizing our understanding of the universe on an almost daily basis. In 2024, an international team of astronomers discovered the two earliest and most distant galaxies confirmed to date, JADE GS Z140 and JADE GS Z14D1, proven to have existed just 300 million years after the previously assumed Big Bang. Both galaxies are once again turning our old cosmological view of the world on its head. In January 2024, the JWST observed the galaxy JRGS Z140 with its NIR-SPEC instrument and found it to be at a redshift of 14.32, breaking the previous record for the most distant known galaxy. This was followed shortly afterwards by JADE's GS Z14D1. Both galaxies show signs of high star formation rates, but by no stretch of the imagination do they look like baby galaxies. They are too large and show too high a degree of order for that. With these two, the list of impossible galaxies is getting longer and longer, and scientists can only marvel. It's not yet clear what these galaxies really mean. Did matter evolve much faster than previously assumed, or is the universe much older? We do not know. Proof of life on exoplanets we've all been waiting for. What many people don't know is that the JWST was built for two primary reasons: to illuminate the beginnings of the universe and to search for traces of life around exoplanets. Both missions have so far proved to be very successful. Although Webb was not quite able to fulfill expectations regarding the confirmation of the Big Bang theory, the telescope hit the bullseye in the search for life in space. The spectrometer analyses of exoplanets thousands of light-years away simply leave researchers speechless. We now have precise analyses of these worlds in our hands, and we could even detect artificial light on these planets. One exoplanet shows such striking features that life there is more likely than on any other planet discovered and studied to date. We're talking about K2-18b, an exoplanet that is 2.6 times larger and 8.6 times more massive than Earth and orbits a red dwarf star about 124 light-years from Earth. This planet is the most promising for the first discovery of extraterrestrial life forms. K2-18b is a so-called Hycean world, a planet that is very probably covered predominantly by water. The scan showed not only evidence of enormous amounts of hydrogen and water vapor in the environment, but also 3 other biomarkers. This is unique, unlike winning the lottery in the search for life in space. Methane is a gas that also occurs on other moons and planets where we have not yet been able to detect life, but on K2-18b it occurs in such interesting combinations that it could be a clear sign of life. The methane is accompanied by large quantities of carbon dioxide, which is a typical residue of biological metabolic processes. So far doubters and skeptics could still put forward non-biological explanations, but now comes the real hammer, and that is dimethyl sulfide, or DMS for short. This gas is produced on Earth almost exclusively by phytoplankton activity in the oceans. There could hardly be a stronger indication of biological processes. The combination of these biomarkers in the atmosphere of K2-18b is a real breakthrough. Now our scientists and engineers have to start thinking and working again, for how can we get even closer to such worlds, and how can we possibly even study their surface? Only time will tell. Revolutionary advances in quantum computing technology. Did you know that a quantum computer can theoretically solve all our problems? Quanta are the ultimate information storage devices in the universe, and they are enormously computational and powerful. We are currently at the very a 6.5 m mirror, a sun shield the size of a tennis court, and a complex array of instruments cooled temperatures near absolute zero. The telescope observed the sky in infrared radiation, revealing details of the universe just after its birth 13.8 billion years ago. It captured images of stars born in clouds of dust and collect faint lights from the deep bits of the universe, exploring the darkest corners. The infrared instruments of the space-time network are also useful for studying strange and bizarre worlds. In particular, James Webb has focused on Proxima b capturing the sharpest image of our closest known neighboring exoplanet. What's fascinating is that what he has revealed goes beyond our expectations. In January 2024 we have reached a remarkable milestone in our understanding of the universe. For millennia humans have observed the sky, wondering about points of light in apparent infinity. Just 3 decades ago, we began to discover planets orbiting other stars through a variety of methods. Now 55 confirmed rectal planets and 10,000 additional candidates. We are in a new era of astronomy, exploring fascinating and diverse worlds beyond our own solar system. Planet formation exhibits remarkable diversity determined by a number of factors, including the character composition, geological activity, and atmospheres. When findings point to the presence of worlds with chemical elements even superficially related to life, the discoveries are significant, providing answers to some of our questions about the cosmos. However, deeper questions remain in this context. The mission of the James Webb Space Telescope is focused on exploring the atmospheres of exoplanets for signs of life in other corners of the universe. Although James Webb is an infrared telescope, which raises the question of its suitability for studying actual planets, it will use a transit method for this purpose. This method involves observing the light from a star as a transitant planet passes between the star and us. Collaboration with ground-based telescopes will complement this research by allowing measurements of the mass of planets using the radio velocity technique, which detects the slight wobble induced by a planet's gravitational tuck. In addition, J. Webb will perform spectroscopy of planetary atmospheres and carry coronagraphs to obtain direct images of nearby exoplanets. Although these images may appear to be simple points of light, their detailed analysis will reveal valuable information such as color variations that may indicate seasonal or rotational differences in vegetation. Spectroscopy, which involves measuring the intensity of light at different wavelengths, is fundamental to unravel the atmospheric compositions of exoplanets. When a planet transits in front of a star, starlight passes through its atmosphere, and the elements in compounds present in the atmosphere absorb light at characteristic wavelengths. This absorption is reflected in the observed spectrum, making it possible to identify the presence of elements such as sodium, methane, or water. An infrared telescope is essential for characterizing the atmospheres of these exoplanets, because many of the gases relevant to the search for life, such as water and carbon dioxide, emit and absorb light in the infrared range. In addition, this wavelength provides a valuable information about the temperature and chemical composition of the atmospheres, which contributes significantly to our understanding of the habitability of these distant worlds. Observation in the infrared